This video demonstrates how to use Promethease as of July 2013. To begin, I'm going to need a copy of my genome. If you don't already have your DNA, there isn't much that we can do for you. My DNA has already been analyzed by a company named 23andme.com. So by visiting 23andme.com/YOU/download, I'm taken to a page where I can go ahead and log in and download my information. I'm going to put in my password. And download, in fact, not my data, but the example data from Lily Mendel. Now that I have my data locally, I can come back to Promethease.com. You'll notice perhaps that it's an HTTPS for improved security. The files from many companies, Ancestry.com, Family Tree DNA, and many more are all understood. You can upload any of them. But I'll click on Upload from your computer, and here in my Downloads directory, the same place where I downloaded the Lily Mendel genome, I'll choose that file, and you'll see a progress bar as the upload is transferred. If you don't see that kind of a progress bar, perhaps you're using a very old version of Internet Explorer, and updating to a recent version of Chrome or Firefox is strongly suggested because other features later on may also have problems. It recognizes this as a 23andMe formatted file and tells me I need to go ahead and pay $5 from Amazon.com. I'll click on this button. It remembers me at Amazon. I will put in my password. Notice this is a different user. The account that you use for Amazon is not necessarily the one that you'll be using for your 23andMe or Ancestry or whoever gave you your data. Because I bought books and things previously from Amazon, it already has my credit card and knows me. I'll click on Continue and just put in the CAPTCHA information to verify that I'm a human. Confirm the payment. And after about 5 seconds, I'm taken back to the Promethease.com website, where it now recognizes the payment as complete. I'm given the choice to pick an ethnicity. It's not essential that there be an ethnicity close to yours in here. For many of us, we're a little mixed or we just don't fit any of these categories. Pick whatever's closest. It doesn't really matter. It does influence the sorting order of some parts of your report, because we know certain things are more common or more rare in some of these populations, but fundamentally all the same information is in there, and everything is fundamentally the same. By putting in an email address or a nickname for this, when the report is also emailed to you at the end of the run, you'll be able to have a record of it that way. For 45 days, you can retrieve the file from our servers, and after that point, your data is simply gone. We retain your report for 45 days, but the data that you upload to us, your raw data, is deleted seconds after your report continues. We really do want to preserve your privacy as much as we possibly can, and I think we do a very good job of that. If you have more questions about our privacy policy, the front page of Promethease at the bottom has a note about privacy and some text to explain all of what's going on. So it takes about 30 seconds for Promethease to recognize that you have made your payment and that you've filled in your forms, and at this point the processing really begins. This will typically take about 4 or 5 minutes. That may change in the future, either up or down, as I modify how the server works. And while you wait, there's a video down here that you can watch. The video is meant to help you understand how to read your report. Today I'd like to demonstrate some of the features of Promethease reports after 0.1.126. But I'm going to go ahead and pause that because that report video is now increasingly out of date, and what I'm recording now is probably what you're watching while that report runs. While we wait, I do want to point out one aspect of this video that I think is interesting to note. If I back up to the very beginning here, you can see that we were working in version 0.1.126 in January 20th when I last recorded that video. And at that time there were 14,000 200 genotypes annotated. In just a few moments, we'll be seeing what a report looks like about 6 months later, with the latest version, which is currently 0.1.156. And instead of 14,000 genotypes, I believe there's now about 17,000 genotypes that will appear. So what you can see is that both the software of Promethease is continuously being improved. There's been 30 versions in the last 6 months, apparently. Oh, I take that back. That was a year and a half ago, so 18 months ago. But also that the content in Snipedia, the number of SNPs for which we know some kind of information, because additional scientific literature has been published, new papers in PubMed, continues to grow. So there is a reason to come back and run a new Promethease report at some frequency. Some people may want it once a year, some people may want it once a month. Even if you run it just a day or two later, usually a couple new SNPs will appear. And so after just about 5 minutes of runtime, the Promethease report has been fully generated. You've also received an email, but I'm going to go ahead and just click on the download button and bring this report in. Currently you'll see that it's a 32 megabyte file. If you're working with Family Tree DNA, Ancestry, or others, each of those has a different collection of SNPs on the chip that they test, and the size of their reports will be different, and what content is there will be different. Now this part here is actually the most complicated piece, it seems. Windows makes it a little bit too easy to go into that zip file but to not actually open it up. So I'm instead going to say show in folder. And now here it says report, that's my download. It's a compressed zip file. And by right clicking on report, I can say extract all. And under Windows, this gives me a way to go ahead and actually open up all of the files that are inside this collection. Because the Promethease report is not a single file, and yet we have to make it a single download. If you're working under Macintosh or other operating systems, your mechanism for unzipping is up to you, and I'm sure you can figure that out. So now I've been taken into the report folder that was just uncompressed. You'll see there's both report, an HTML file, and a directory of supporting data. And by double-clicking on the report, I'm taken into the current report. And so here you see version 0.1.156, the date on which this was generated, July 23rd of 2013, and that almost 18,000 genotypes, 17,809, are currently known. You can click on good news and see just the good news, and you could scroll through here, the same for bad and interesting. There's a section just on medicines, but I really want to begin at what I think is the most important, most interesting, and most useful place, the so-called UI version 2 interactive report. This is a continuously updated software I'm trying to put together to make it as easy as possible for me and for you to explore all of these 17,000 plus genotypes of information. It's a lot of information, and there's no one single best way to represent it. So here you can see that there's boxes outlined in gray, which are not necessarily good or bad, such as gender, eye color, hair color. Things outlined in green, which are considered good, and things outlined in red that can be considered bad. How high up something is in this order is a function of a parameter we call magnitude, and you could filter by it over here. We'll discuss it a little later in more detail. But magnitude's the way that the community decides how important is something. Is a 2x risk of Alzheimer's more important than a 1.6x risk of prostate cancer and other cancers? Well, so far it seems so, but we only think that by a little bit, 3.5 versus 3.2. And then eye color is just a little bit further down, and for you, the order of all of these things will be different. Some things won't be known. It may not be possible to classify your eye color or other features quite as well. But you can come down to the bottom of this and see some of the kinds of things that we are able to classify. And so far, only the first 10 are visible on screen, while 17,000 plus are still off screen. So clicking 2x more will double the number that's on screen, and I can continue to scroll through here and explore deeper and deeper into my data. What I want to point out is that there's just too much to really display it all at one time, but I can begin to say, well, there's certain topics I care about. Maybe it's CANCR, and now all of the SNPs that mention cancer are brought to the front. And now it's a much smaller list. Now there's only 800 of them. And the pie chart has been updated to reflect how many of the ones that are currently on screen are considered bad, apparently 16 of them. 195 are classified as good news, and the majority, 75% of them at 618 total, are still not yet classified as clearly good or bad. However, you'll notice the bad ones in red tend to be at the top. Good news is usually pretty boring because you probably don't have any superpowers hiding inside your data. And so a lot of the good news is down at the bottom while the bad news tends to be at the top. And I've seen some people get a little worried about this because the first thing they see is the bad. But if we showed you all the places where you're normal, you'd be a little bored. So right now we're searching for all kinds of cancer, but I'm going to go ahead and get a little bit more specific here and pick just the category of lung cancer. We're still searching and filtering by the word cancer, but instead we've come to this other section. And here are lots of different topics like longevity, leukemia, leprosy are all here. And I'll get rid of the word cancer because we're still filtering by that. So we'll go ahead and get rid of it, and now you'll see that there are 6 leprosy-associated SNPs which are not yet classified as good or bad, and 1 which is classified as necessarily good. So most of these are just not yet known, but by looking at the frequency, this is the frequency in the chosen population, the CEU Caucasian population, we can see that 30% of people have this genotype. If 30% of people have it, it certainly is unlikely to be particularly bad and rare. There are some where that's the case. Let's go ahead and do a different search. I will get rid of the category of leprosy and instead look at things that have already been classified for DEA. And we get breast cancer or breast size. And we'll focus on breast cancer as it's a more interesting topic for most people. And here we can see the top one is a higher cancer risk. The things that you see in this gray box are specific to your genotype, specific to being a CC at this location. By clicking on more, you get more information about the position generally. And so the information in this box, or by clicking on more info, is the same information that you would get by clicking not on the genotype, but instead over here on the RS number. RS numbers are standard identifiers from the NCBI, the National Center for Biotechnology, at the NIH, the National Institutes of Health, .gov. All of these have been assigned these names by a U.S. government authority. And by clicking on the information here, I can see all of the information that we have already collected about this position in the genome. Generally, there's a PMID number that's a link off to PubMed and a brief summary of it, often just the title of the paper. The gene that it's in, the chromosome, frequencies, position, and all kinds of other information are already classified here. Generally, newer papers are down at the bottom because they're populated automatically on an almost every night basis. But sometimes the important summaries are sitting up at the top. In this case, that's not really the case. There's a few other details I can point out here on the right-hand side. We've classified that CC is bad in red, with a magnitude of 2.5 and the one brief summary of higher cancer risk, while as GG is considered good and normal. And you can look then at the frequency of the different genotypes in different populations. Here's that CEU that we chose for Lily Mendel, and some other ones. By clicking on the question mark, you'll get information about each of those codes, but they roughly correspond to Caucasian, Chinese, Japanese, African, African American Southwest, and a few other populations like Gujarati Indians, Mexican population, and Tuscan Southern Italian, along with the average of all of these. And what you'll see is that, for instance, the CC genotype, here colored in brown, is fairly rare in Caucasians, but relatively common for the Chinese and Japanese populations. So the overall frequency is about 20%, whereas the blue GG is really quite common, occurring in about 50% of all Caucasians. At this point, I'll come back. Actually, no, I will click on one of these PubMed IDs and see what we can learn about it. By going off to PubMed now, we're at that nih.gov address. You can read the abstract of the paper, sometimes see some figures, and when you're really lucky, you can go ahead and click on one of the links here and read the full absolute paper for yourself. And that's exactly what we've done to go ahead and fill in the information that you see so far. But we're very much reliant upon you and people like you to come in and help fill in information into SNPedia so that we all learn more about our genome. So we've seen a little bit of how you can do filtering. I'm going to go ahead and sort not by magnitude, not by the things that are already classified as being very important, but by frequency. Frequency is a good way to find things that are fairly rare and specific to you. And in fact, I'll even take it off of breast cancer, and I'll come back and just show all. And now we can see a particular SNP here. Only 0.9%, so just a little under 1% of Caucasians have this AA genotype. And apparently it slightly increases the risk of prostate cancer. By clicking on more, I can see some of the more information about it. Clicking on more information would again take me into that page in SNPedia, and I could see that it's not just rare for Caucasians. That AA is rare for every population, and GG really is much more common. So we'll come back into the UI2 report. We will again sort by frequency. And here's this genotype. But nobody has yet classified this one as good or bad. I think it's pretty clear from the description here that it should be bad. So I'm going to go ahead and click on AA. I'm taken in not to the general page about the SNP, but the information specific to this genotype. Somebody has already filled in the summary, slightly increased risk of prostate cancer. But by clicking on Edit with Form, I'm going to go ahead and actually change the repute so that this becomes officially bad. I'll leave a brief summary. Hopefully so you could have something better to put than that in most cases. And you may, if you're not logged in, have to go ahead and do a CAPTCHA to prove that you're a human. With that, I'll scroll to the bottom and click Save. And that's it. I've just made SNPedia a little bit better, and I've made all of the future Promethease reports a little bit better. So anybody else who shares this fairly rare genotype will immediately see it classified into the bad categories. So you've got a sense of what you can do here. I will point out that this one was notable because it had 15 references. 15 papers were already linked back on that RS number page in SNPedia. The next one is also quite rare, at a little less than 1%, but there's only a single reference. If I click on the RS number, we'll see that. In this case, there's one paper relating to bone mineral density here in the GWAS. And, well, it's interesting, but I don't really want to think about the ones that only have a single paper. SNPedia has to capture them because we can't know that it has 15 papers unless we first know that it has 1 and then 2 and then 3. But I'm going to go ahead and click on plus, or you could use the slider and say, you know what, I only want things that have at least 12 references. If there's 12 papers, okay, now I believe it. And we still see the one that we saw a moment ago, but a bunch of others have been dropped out as not yet particularly credible. And we can instead focus on just the ones that have more information. And when I do this, I've got 10 SNPs on screen visible at the moment. If I scroll to the bottom, you'll see them. I'm going to go ahead and switch out of here. And I'm going to switch over to a particular topic like, let's see, age-related macular degeneration. There's a fairly classic SNP in here, one of the early ones that was found with the genome-wide association studies. But these SNPs are not necessarily exclusively related to one particular condition. Here we see age-related macular degeneration a couple times over, but this one, which has that association, also relates to HDL cholesterol and LDL cholesterol. If I click on Graph, I get this other window. It's a little bit off screen at the moment, but by positioning and then using my mouse wheel to scroll, I can zoom in a little bit closer and see some of the different associations that are present for this. So this particular topic here has all of these red and green SNPs around it. but we'll see that some of them relate to things like longevity and the 2 cholesterol SNPs that we just talked about. And I'm going to leave age-related macular degeneration and instead search for, let's say, cancer. We'll pick bladder cancer. There's just 13 of those. And looking at the graph for this one, what other things are associated with the SNPs? Because it isn't as if there's a SNP that's just the bladder cancer SNP. It turns out that we see associations with colon cancer, prostate cancer, and liver cancer for some of these, whereas other ones only have a fewer number of associations like gallbladder cancer or gastric cancer. So the graphs can be a good way to get an overview for the associations of all of the different medical conditions that are relevant. I'm going to click on Help and then come back to the main report. So UI2 is probably the best way to really explore your data, but sometimes you know that there's a particular medical condition that you care about, or more importantly, I think, medicines. People often look into this genetic testing and they focus on diseases, but genetic diseases are often something that you kind of just have this increased risk for, and there isn't often a lot that you can do about it. Your doctor will tell you to eat right, exercise, don't smoke, but the things that I think are really valuable are the medicines. Medicines really influence decisions that you and your doctor can make together and consider whether or not certain medicines might go ahead and have a high risk for you. I think for Lily Mendel, there's nothing that really jumps out, but we can see that, for instance, for Allegra here, she does have one SNP classified in red, and therefore there's something that she has. She's a heterozygote for it, and there's information in here about all the different drugs that this one affects. So if she's considering taking Allegra, there's reason to click through. And really, before taking any new medicine, I think it's worthwhile to consider skimming through here and considering what kind of reactions you might have. Let's see if we can find something particularly interesting. Well, not the most interesting, but a good mix of things. Clopidogrel, I don't know much about it. But I can see that there's most things classified in as green and good, 1 or 2 things classified in gray as not yet classified, and red as bad. And so here's a few things which she'd want to know if she's about to take that medicine. And it looks like she's a CYP2C19, that's a particular gene. She's the type 17 ultra-fast metabolizer, and as a result, she breaks down certain medicines more quickly. Clicking on more here or the RS numbers as before can tell me more about that. And so with that, I'll come back to the main report, show you that it is possible to drill deeper and deeper and deeper into your data. There is a lot of information in here, but the sections you've seen so far really are probably the best places to start. And if you really want to dig a lot deeper, there's also a tab delimited file that you could open in Excel if the reports that we've got here aren't the right way. With Excel or other tools for processing tab delimited files, you should be able to really explore it any way that you want. Okay, I hope that's a helpful introduction to Promethease. I hope you'll consider contributing what you learn about your genome back into SNPedia and help all of us learn more about ourselves. Thanks.